students, today's agenda is to check homework. We'll be proving diagonals congruent, and you will be able to work on 10.7. Today, students will be able to prove a figure by its characteristics, and again, it's going to be in relation to the diagonals. This is the information that we will need for this lesson. Figures with congruent diagonals, meaning that they have the same measurement, are squares, because if you draw their diagonal, they're going to be the same measurement. Rectangles also have congruent diagonals, and isosceles trapezoids also have congruent diagonals. So diagonals are these green lines that go from one corner to the other corner, but not next to it, because that will be the side. We will also need the distance formula, which we learned before, but it's d is equals to the square root of y2 minus y1 squared plus x2 minus x1 squared. In this format, which is exactly the same, all they're doing is switching the difference of the x and the y's. In here you have x first, and then in here you have y second, okay? So same thing, whichever you feel more comfortable with. I'm going to be using the first one, just because it relates a little bit to the slope, okay? The order of the slope. Here's number one, and it says to prove that the diagonals are congruent. This is a square. They give us one measurement, and by going with the previous lesson, if this is A, that means that from here to here is A, and from here to here it's also A. So to find this point, we have the same measurement. And sorry that is not perfectly to scale, but this is the same measurement. So, but it's going to the left, so it's going to be negative A for x, and it's going up, so it's positive A. So negative A, positive A. For this one right here, negative A, because it's the same measurement. So negative A for x and negative A for y. And for this point, it's going this way and this way. So it's positive because it's to the right, and then down is negative. So it's positive A for x, and then negative A for y. Okay, so now that we have all four coordinates, we can check with the distance formula. D is equals to, I said, to always put this first. It's like the eyelashes, ojos coquetones y dormilones, okay? So the minus is like your eyes are closed, and then these are the eyelashes, coquetones y dormilones. So it's gonna be y2, y1, x2, x1, and again, remember that this can be switched, these two parentheses. So it's going to be the same whether you use the x's first or the y's. So it's going to be, let's say that I want to find the distance between these 2 points, which is the diagonal. So between point, let's name this as A, B, C, and D. So between A and C, the distance between A and C is going to be equals to, so let's put the points in here. For point A is negative A, positive A. For point C is positive A, negative A. And then we can start plotting, or we can start. So now we can substitute the values of these as x1, y1, x2, y2. And this just represents 0.1. That's why it has a 1 for x and y, and 0.2 for x and y. That's what the 2 represents. And so now we just replace the y2 is this negative A minus from the formula y1 is A, and then you square plus x2 is right here, so it's a minus x1, it's negative a, so be careful, it's negative from the formula, but then this has a negative, so it's two negatives together. And don't forget the eyelash, the square in there. Now I want you to remember that when you have two negatives right next to each other, not like this one that they're separated by the a, but right next to each other, they cannot get along. Negative times negative is positive, or the big plus, so it disappears. Right now you have a big plus in there. So now let's simplify that. Negative a plus negative a, it's going to be negative 2a squared. So we're simplifying inside of the parentheses first, and just bring this down. A plus a is 2a squared. And so in here, what we get, negative 2a times negative 2a becomes positive 4a squared, plus 2a times 2a becomes 4a squared. Since both have like terms, because they have the same variable raised to the same power, then we can just add or subtract the coefficients. In this case, both are positive, so it's going to be d is equals to the square root of 4 plus 4 is 8a squared. Now in here, this can be simplified, and let me do the number on the side, which is an 8. You just put 2 times 4, 2 times 2. We group two of them, and the lonely one stays inside of the little house, okay? For the ones that are in groups, remember that we cross one out, and so the answer is equals to a whole 2 and square root of 2. For the a square, the square root cancels the square, and so the answer is going to be like this. 2a square root of 2. Now again, why for the a do we disappear the square? Is because this square root cancels that, okay? Or if you think about it, just like we did a pairing here, we cross one out and then this one goes outside. Okay, so that's going to be the answer for one of them. So that's the measurement for point AC. Now, what about point, and it doesn't matter which one you put first, it can be BD or DB. Okay, so let's do B, point BD. So the coordinate for B is AA, which is both positive. The D is negative A, negative A. And now we start with the distance formula. So D is equals to, remember the eyelashes on both, the minus in the middle, and then we start, remember that this is x1, y1, x2, y2. So at the beginning we have y2 is negative a, and let me put that formula right here so you can see it. Okay, so y2 minus y1, so y2 minus y1, minus from the formula, but then this is positive, so you just put the minus from the formula and a. Then x2 minus x1, x2 is negative a, minus from the formula, and then a. Then we have negative a, and negative a is negative 2a. Bring down the square. Negative a is negative 2a. Bring down the square. and that becomes negative 2a times negative 2a. Remember that this tells us that the whole thing multiplies times itself 2 times. And in both cases, we're going to include that negative, so negative times negative becomes positive 4a squared. Plus, negative 2 times negative 2 is 4, and a times a is a squared again. We have 4a squared plus 4a squared. Again, because they have the same variable raised to the same power, they are like terms, so you just add the coefficients, and 4 plus 4 is 8a squared. For the a, this cancels with this, but not for the 8. Remember that we have to do it on the side, which you have right here. How do you do that? We saw it in quarter 1. So all you have to do is prime factorization. So it's 2 times 4, 2 times 2. We have to find pairs because the index is not there, so it's only 2 in each group. Since this 2 is lonely, that's going to stay inside of the square root. From the pairs, we keep the captain, but the other ones don't go in there. So it's 2 goes outside. The lonely one goes inside. For the a, same thing. We're doing a times a is a squared. It's a pair. Get rid of one and just get one outside. Remember that because it's a variable, it goes between the whole number and the irrational number. So the distance is equals to 2a square root of 2. Now we go ahead and compare the two answers, and we see that they are the same. The distance for both diagonals are 2a square root of 2. That means that they are congruent. They have the same measurement. Okay? So make sure that you pause the video so that you can copy this, and let me give you another example. Okay, so this is number 2. And the first thing that we need to find is the points, just like we did in 10.6, these 2 points. And whenever the point is right in the origin, remember that that's going to be always 0, 0. So this is the one that we found, right? And then for this one, we have to see, because it's not this measurement, which that measurement is C, just because they're giving us this point, we know that that's up to here, from here to here, that's C. We don't know how much that is, but we know that it's represented by letter C. It can be 8 units, it can be 5 units, it can be 3 units, we don't know. But to get to this point, we need to add this extra section, right? It goes up like this. So how much is that section? If you notice, this figure is slanted with the same measurement from here to similar to this side right here. Okay, so this is the same as this one. Okay, and so we can say that this is A, because we got on X is A and then up is B. So this is B. This measurement is A, so it's A in here. And this measurement, we already, because of this, we found out that it's C. So for X in here, we have to add these two together, which is C and A. So C plus A, which is in alphabetical order, will be A plus C. Okay, we're putting the A and the C together because that's how much space we go on X, and then we go up, which is comma B for Y. So my X is A plus C, my Y is B. Okay. So now I have all 4 points. Let's name this as, and I'm naming this afterwards because I don't want you to think that this, oh, this is A because it has A in there. No, that has nothing to do with it. So maybe I'll name this one as point A. This one as point B, this one has point C, and this has point D. Okay, again, it has nothing to do with the measurements. The measurement is just from like how much space is there, okay? And it represents a number that we don't know. And the reason for which there are different variables is because they are different. However, from the x-axis going up is B, and from here, this is also B because it also goes up the same amount of space, okay? Okay, sorry that I'm taking a little longer for that part, but I hope that helps. So now we're gonna do diagonals, and let me use a different color. We're gonna do diagonals, and we can immediately see that they are not congruent, but it's just to show you how they are going to be different, okay? Again, as you saw at the beginning, only squares, isosceles trapezoids, and rectangles have diagonal that are congruent. This is a kite or rhombus, so which don't have congruent diagonals, okay? So now let's look at AC, okay? Let's do point AC, which is the measurement of this big diagonal. So the first point is 0, 0. The second point is A plus C for X, B for Y, okay? And so this is X1, Y1, X2, whoops, more this way, Y2, hopefully that doesn't confuse you. And so the distance is, let me separate this here. The distance is equals to the square root of, let's put these ojos coquetones y dormilones, right? Sleepy eyes, because they look closed, and with the nice eyelashes. So Y2 minus Y1, X2 minus X1. And so Y2 is B minus 0. And then X2 is A plus C minus 0 square. So the distance is B minus 0 is B square. And then in here, A plus C minus 0, basically when you subtract 0, that nothing happens. It's just A plus C square. And so we just bring down the B square plus, remember that when we have a binomial, you have 3 different terms. Okay, the first one is that you get the first one and square that, so it's A squared. The last term is that to the second power again, squared, so it's C squared. But for the middle term, you will always multiply the first term times the second, so A times C is AC, times 2 is 2AC. And since that's positive, you just put a plus in there. Now, there is nothing that can be combined, so I'm just going to kind of arrange it in alphabetical order, although it can be a little tricky, especially with these two. So it's going to be A squared plus maybe 2AC plus B squared plus C squared. Okay, so that's one of the diagonals. That's the distance between these 2 points. Now let's look at the other one. Okay, so the distance again is equal to Y2 minus Y1, and then X2 minus X1. Let me put the points up here, which is point DB. And again, it doesn't matter which one you put first. So for DB, you have the first point is, let me put it right here, A comma B. And the second point, which is B, is C0. So this is X1, Y1, x2, y2. Okay, and now I can substitute those values. So y2 minus y1, y2 is 0, minus y1 is b, plus x2 minus x1, so that's c, and don't forget the 2, so c minus a. In here, just because we have this 0 minus b, we do need to put it between parentheses just because of the minus. 0 minus b is negative b squared, plus, in here, again, we can do the binomial, the perfect square, times 2. And so it's going to be c times c is c squared. A times a is, even if it's negative, negative a times negative a becomes positive a squared. And then for the middle term is c times negative a is negative ac times 2 is negative 2ac. Okay? And so negative b squared is negative b times negative b, so that becomes positive b. D is equals to b squared plus c squared minus 2ac plus a squared. So now let me arrange it a little bit, comparing it to the other one and trying to put it in alphabetical order. So it would be a squared, it's positive, and then negative 2ac, negative 2ac, positive b squared, and positive c squared. So if you notice, they are not the same, and that shows and proves that just because of this difference, they are different measurements. In one of them, if you subtract a multiplication, it's going to be a lot short. I mean, it's going to be shorter than when you add. Okay. So in here, we can say a rhombus, the diagonals are not congruent, okay, unless they are r square. So with that, you're able to do 10.7 and have fun.